Hello, this is Matt Roscoe at the University of Montana with a short lecture on our Concepts and Measurement chapter for Math 133 Geometry for elementary school teachers. Sorry I couldn't be with you today, but hopefully this video will get you started, and let's get right into it. So I'd like to go over an opening question, talk about the two systems of measurement, then do a brief discussion of conversions, and then give you a few measurement problems to think about after having read the chapter. So here's the opening question. Each of the trees described below could perhaps qualify as the biggest tree in the world. Compare the trees. Why can reasonable people differ about which tree is biggest? So why don't you pause the video here and just take some time to read each one of these and ask yourself, which one of these trees would you say is the biggest, and why would it be reasonable to expect that people might differ or have different opinions than you? So go ahead and pause. Okay, so perhaps you had some time to think about that now. It seems like, reasonable people could differ about, which trees would be the biggest. If we were to go for the tree with the biggest height, one of the things that you might, look at in terms of which tree would be the biggest height, in terms of ranking them as biggest, then maybe the biggest height would be something like, is it the Mendocino tree? Yeah, it's the Mendocino tree, which is... it's the tallest tree, right? But maybe you would go with volume. If you went with volume, at least the volumes that we've been provided, it looks like General Grant is the biggest tree. If we went with circumference, it's hard to tell here, really, right? The circumference of the banyan tree in Kolkata, India is certainly very large, but it's the circumference of the whole tree, not just the trunk. And then 40 people holding hands to encircle it. Let's say, the 40 people are, holding hands to encircle it. How are they actually, so this is sort of perhaps larger than, if we're just talking about the measurement around the trunk, assuming people might be largest. But, we also have a circumference of 108 feet here at its base. So it's sort of a question, I guess, about which one has the largest trunk. Oh, I noticed I actually made a mistake. It turns out this guy had the largest volume, right? 52,500 cubic feet is larger than 46,600 cubic feet. So it sort of makes sense that, reasonable people could differ. And what this gets at is this idea that when you're given an object, there are different things you can measure, and we call those different things measurable attributes. So for a tree, we can measure things like circumference, which would be sort of a two-dimensional measurement, or volume, which is a three-dimensional measurement, or height, which is a one-dimensional measurement. So all of these different, measurements are measurable attributes, and we've got to first decide decide which measurable attribute is important before we can rank things. All right, well, sort of kind of a nice start. Two dominant systems of measurement, you should be aware of this, U.S. customary and metric. Your table in your book gives a nice summary of all the U.S. customary measurements. For length, we have the inch, foot, yard, and mile. Area, we have square inch, foot, yard, mile, and acre. In volume, we've got cubic inch, foot, yard. In capacity, so this is teaspoon, tablespoon, fluid ounce, cup, pint, quart, or gallon. And then finally, weight, we in the U.S. customary system use the ounce, the pound, and the ton. And for temperature, it's Fahrenheit. There are some interesting things here off to the right that you should probably, I want to draw your attention to a little bit, but for example, we know that 1 foot is 12 inches, 1 yard is 3 feet, and then 1 mile turns out to be 1,760 yards or 5,280 feet. So, conversions over there, how to get from one to the other. But perhaps kind of more interesting would be when we convert from units of length to units of squared length or area. Why in the world are there 144 square inches in 1 square foot? Or, for example, in 1 square yard, why are there 9 square feet? This is something maybe we should talk about really quick. Make sure that you're aware of what's going on there. Let's take the 1 square foot, 144 square inches question. So on the next page, I have here drawn something that we'll say is 1 square foot. Okay, so if it's a square foot, that means that it measures this distance is going to be 1 foot, right? And I guess this distance here, I'll try to do it the same distance. Let's see, so about there. It's going to also be 1 foot. But we know that a foot is 12 inches, right? So another way of thinking of this is 12 little inches, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 inches, right? So these are inches. And of course, that's the same thing going on here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 inches. So these are inches. So if we were to look at a square inch, I mean, what we would be really looking at would be, so I'll just put this. So a square inch is really one of these little tiny things here, right? It's one of these. So if I have a square foot, the question would be, well, how many of those little square inches are actually in a square foot? And of course, we know that since area is equal to length times width, right? The number of square inches in there is going to be 12 times 12, or 144 square inches. So you can see that what happens here is if you have a length conversion, you have to square the length conversion, 1 to 12, to get the area conversion. So for example, you know, one foot equal to 12 inches then becomes 1 square foot, I guess I want to say, equals 12 squared square inches. That is 1 square foot equals 144 square inches. I hope that makes sense. But that's what's going on here. That's why 1 square foot is 144 square inches. You can kind of imagine 1 square yard then being, well, a yard is 3 feet on a side, so 3 times 3, 9 square feet. So you can play the same game here with cubic measurements. So again, now you can kind of think of a cubic foot as a box that has 12 inches length, width, and height. And of course, the volume of a box is length times width times height, or a cube. So it would just be 12 cubed, and 12 cubed is 1,728. So it turns out that there are 1,728 cubic inches in a cubic foot. And yeah, cubic yard is the same thing. It's going to be 3 feet on a side, so 3 by 3 by 3. We multiply those 3 to get 27 in that conversion. The measurement units of capacity, of course, are you know, the measurements here are just accepted by you know, conversions. So 1 tablespoon is 3 teaspoons. A fluid ounce or liquid ounce is equal to 2 tablespoons. A cup is 8 fluid ounces. A pint is 2 cups, 16 fluid ounces. A quart is 2 pints, which is 32 fluid ounces. And a gallon is 4 quarts, or 128 fluid ounces. So a lot going on there with units of capacity. And then finally, we use the ounce, 16 ounces in a pound, and 2,000 pounds in a ton, in degree Fahrenheit for temperature. So quick ramble through U.S. customary units. let's take a quick look at metric units. The first thing you need to know is that there are prefixes for metric units. These should not be new. They go from nano, micro, milli, centi, deci to deca, hecto, kilo, mega, giga. I guess the first 5 are ones that make the measurement smaller, the prefixes that make the measurement smaller than the unit measurement, and the following 5 make the measurement larger. So they're all powers of 10. The ones that we'll deal with a lot in this class, of course, will be centi and kilo. We won't get into a lot of nano, micro, and also milli. But these are the 3 real popular ones for length measurements, ones that we see the most. But of course, if you're working in the sciences and you're measuring something really small, you might see nanometers or micrometers. If you're measuring something very, very big, let's say in physics, you might see something like a megameter or a gigameter. So that's the idea, prefixes. So in terms of length units, we have the millimeter, the centimeter, the meter, and the kilometer. These are the most common ones. So the millimeter would be 1,000th of a meter. Centimeter would be 1/100th of a meter. The meter itself is 100 centimeters, I guess, or think of it as the base unit. And a kilometer would then be 1,000 meters. Squaring each one of those gives you measurements in terms of area, so square millimeter, centimeter, meter, and kilometer. And of course, you see the same thing going on here, that when we square the length conversion, we get an area conversion. So if there's 10 millimeters to a centimeter, that means that there's 100 millimeters squared to 1 centimeter squared. If there's 100, let's do this one, if there's 100 centimeters to a meter, so this one gets converted via squaring to this one. 1 meter squared is going to then be 100 centimeters on a side, so I would square 100 and get 10,000 square centimeters in 1 square meter. In terms of volume, well, they just provide cubic millimeter, centimeter, meter, and kilometer. So again, we can just cube things, for example, to get cubic conversions. So for example, we could kind of think of the length conversion being cubed to get a volume conversion. So 1 to 100 meters to centimeters becomes 1 to 1,000,000 cubic meters to cubic centimeters. Let's see, so in terms of capacity, the liter is the unit of capacity. We have both the liter and the milliliter. A milliliter is 1/1000th of a liter. And then units of weight, the gram is the unit, and milligrams would be 1,000th of a gram, whereas a kilogram would be 1,000 grams. And degrees Celsius is the measurement of temperature. It's nice that this has a very, I guess, simplistic 0 and 100 scale related to water. So 0 is the temperature at which water freezes in Celsius, and 100 is the temperature at which water boils. So quick description of the common units of measurement in the metric system. So since we have these two systems, we have to be able to convert between them. So it turns out that in length, 1 inch is exactly 2.54 centimeters. You read that in your text. It's actually the inch is actually defined as that right now. But in terms of capacity and weight, we have approximate conversions. So a gallon is about 3.79 liters, and a kilogram is about 2.2 pounds. So those are the conversions that we can use to get from one system to the next. And of course, once you have a length conversion, you can get out of that an area conversion as well as a volume conversion. Okay. So one thing I wanted to make sure that you understand is that the metric system has this wonderful connection between length, volume, and mass. So it turns out that 1 milliliter of water weighs, so a milliliter, that's capacity, right? Weighs 1 gram, so that's mass, and it has a volume of 1 cubic centimeter. So the way that I would think about this is I would think of it this way. I would think of it as the cubic centimeter of water. So if you sort of think of this little box, 1 centimeter on a side, right? And if I were to fill that little volume with water, okay, so I fill that thing with water, and this thing is the same thing as 1 milliliter. Okay, so you can kind of think of it as a milliliter is just a cubic centimeter. This is why you hear often, doctors on movies interchangeably use milliliter and cc, cubic centimeter, because they are the same thing in liquid form. And let's see, and it weighs 1 gram, so there we go. This sort of relates weight, or I guess we call it mass, volume, and capacity. And the volume, of course, is derived by our understanding of length. So we have sort of a length volume mass relationship, but also capacity. I forgot to put that up there. So one really nice thing about the metric system is this: it's sort of built around this idea of our touch and feel sense of what water is and how much it weighs. So a little cubic centimeter of water is what defines the gram, or I guess is equal to a gram, as well as a milliliter. Okay, so here come the measurement problems. I would like you to try each one of these measurement problems on your own and to upload them to the discussion 11-1 that I have posted in Canvas. So the first problem is to draw 3 different shapes that have an area of 18 square centimeters. I provided you with some centimeter grid paper, or you can use your own, but draw 3 different shapes that have an area of 18 square centimeters. Okay, number 2 is a construction site requires 13 cubic yards of concrete. How many cubic feet of concrete is that? So if we got 13 cubic yards, how many cubic feet are we talking about? So upload your answer to that. And then which of the following describe or are the same area and why? So 4 square inches, a 4-inch by 4-inch square, 4 inches squared, 4-inch by 4-inch, a 2-inch by 2-inch square, 2 inches squared, and a 1-inch by 4-inch rectangle. So which of the following describe or are the same area and why? And then how much does the water that fills an Nalgene bottle, 1 liter, weigh? Find both a metric weight and a U.S. customary weight. I guess I don't need the question mark, period. Which one is exact and which one is approximate? So upload those to the discussion, and I will count your upload to the discussion as evidence that you've participated in this activity, and that'll be your attendance score for the day in my absence. All right, if you have questions, please email me. I am available over email, and I look forward to seeing you on Monday when I return, and we'll review the problems, I guess your responses to these 4 measurement problems at that time. Okay, have a great weekend, everyone. See you on Monday.